welcome everyone to the fourth part of our 5-part webinar series. Today we will talk about asset process management. Just to give you a short introduction what it's all about today, we are going to, let's say, repeat a lot of stuff which we already have talked about. We are going to show you some applications which you might have already seen in a different spotlight, maybe with a different focus, with a different purpose. And we will also going to show you something which is new to you, which is called anomaly detection. We will give you a short teaser of anomaly detection because this topic is really broad, and we try to inform you as good as we can in this limited amount of time. So that was just a short introduction. We are going now through the regular slides as you know them already. So first of all, housekeeping. You're all muted. For sure, you have a lot of things to say, but you are not allowed, unfortunately. But you can still ask your question in the Q&A section. Click the button, ask your question, and we will answer it at the end of the session. Whom do we have today? Not unfortunately, fortunately, yeah, we are glad to hear that Frank is back and he's not that sick anymore.
Not that sick, just a little.
Just a little, exactly. So thanks for having you here. That's perfect. Frank is really, let's say, important for us since he has a good amount of knowledge in heat treatment, in processes, in software, in automation, in everything. Yeah, he loves QMULUS. He is really passionate, and I guess he will show you that in the live session part of this presentation of this webinar.
Thank you.
And additionally, yeah, we have me, so no more words. I'm also with Nitrix for a couple of time. I am really, let's say, experienced in software development and also in these new kind of applications which we are producing. So yeah, don't waste any more words on me. So yeah, let's start. Where are we in the series? We are the fourth part. I already mentioned that. We had QMULUS basics, audit quality, data analysis and insight. Today, asset and process management. And last but not least, and I think the most exciting will be in February about advanced tech. What is advanced tech, you might ask yourself? It's about AI, how AI is enhancing our other applications, because we have a portion of AI in almost everything. Now we're going to present that in February. Today, we will tease it a bit, but not too much. So we hope that you will be there in February again. So today's discussion will be mainly about anomaly detection. We will have just a few slides to let's say, create a story. But the live presentation will be more like, okay, let's go in here, there, and showing you everything. Then we have the absent spotlight, which will be the live presentation, and for sure Q&A as always. 45 minutes is optimistic. It will be maybe a bit longer today because we have a lot of applications to show and a lot of things to present. Note, again, we are showing the dev environment where our developers are currently hard working on new features, on the stability, on everything what is in regards of software development. That is also the reason why we don't have always real data. You might see that in the audit and quality part, we have just some artificial data, some data we prepared ourselves for the sake of this presentation, but I guess you will grasp the point, and that's it mainly. We'll go into it when it's live. Exactly. So let's go dive into it. The 4 slides we have: case study, anomaly detection, and we are creating a story around it. So scenario 1. The question you will always ask yourself if you're in charge of production, if you're responsible for the production and also for the outcome of your production, is what quality for my product can I expect? Yeah, I have my machine, I have the parts I need to process, I have my process itself. For sure, if everything is beautiful, yeah, life will be beautiful, quality will be beautiful. All good. The parts are in the best shape you can imagine because your contractor is delivering best parts they have in the world, whatever. You have a brand new machine, fully overhauled or whatever. It's in the best state you can imagine. And you have a process which is well shaped and especially made for this purpose. Yeah, everything will be good. There's no question about it. Yeah, if you run your process as it has been designed on the machine, which is in a perfect state with the best parts possible, everything clean. So what shall happen? Quality will be good. Yeah, in many cases, testing might be obsolete. Yeah, for sure, we know that some testing is always needed, and certain customers are also requesting that. Yeah, but maybe we can save some money if we can just have that knowledge that everything is in a good state and the quality we are going to achieve is good. The next scenario is a bit, let's say, the counter side. What if not everything is good? Yeah, for example, my machine is really in a bad state because I know that maintenance has to be done in the next week already because the filters are clogged, whatever. Yeah, so the insulation is a bit broken. The fuel or the tanks are not filled completely. I don't know. Yeah, all these things. Everything comes together. Everything what could have a worse impact on my process or my machine is coming together. So it's really in a bad state. Yeah. And also my process. I never process these parts. I know it should work, but I'm not 100% sure maybe. Yeah, so I'm a bit off. And the question is then, okay, what is the expected quality? And the quality is in general, we can just call it questionable. That's what I wanted to call it. And in worst case, it's even poor. And this is something we would like to avoid. And there are these questions popping up. Yeah, so what can I maybe statistically determine the outcome of my process? That's why it's written here. And how can I streamline my current process to be the best process I could run for this particular piece, for this order, for example? So that is called somehow scenario one. I think you already have noticed in which direction we are yielding here. Scenario two, also, it's same direction. You receive your parts from your contractor, in-house, external, whatever. They are really expensive, and you have to run a process which is high sophisticated, really complicated. Maybe you've never done that before. But the most important thing is the parts are expensive. Maybe they are huge, and the contractor does not have multiple of these. So then the question is, can I really run this part on my machine, which is currently available? In that state, the machine is currently available. So first thing we would do is going to your machine, maybe going to your machine, but virtually going to your machine, checking the maintenance logs, checking what people are saying, the reports. What are the people on the shop floor telling you? Is the machine okay? Or is there some strange noise? Is there something? Yeah, you would just ask for it. But in the end, you would need to create your own picture. Is it good? Is it average? If it's bad? And then you have to decide. If it's good, okay, easy to decide. The part will be processed on that machine and with that process. If it's on average, you do not really know, it's somehow risky. But yeah, in most cases, it's still okay. You will run it. If you can consider a different asset to run it on. Yeah, but not everybody has. And if you got to know, yeah, that it's in a bad state, yeah, maintenance is up to come next week, you might select a different option. You definitely won't run that part on that machine today. So that is the story. And how can QMULUS help here? So what if I say that QMULUS is providing you continuously with this information? It's giving you the information if the machine is in a good, average, or bad state. You can see that by browsing the dashboards. Now you can just click on the different dashboards and investigate different aspects. For example, we will talk about alarms. We will talk about abnormal behavior. So this is where anomaly detection kicks in. We will talk about the average outcome of a recipe. We will talk about quality in general. So these are things QMULUS can deliver you at hand. You just open your browser, you scroll through QMULUS and just investigate step by step, and you can make your picture, or you can create your picture of how good the machine is, the process is, by yourself within minutes. So that's it for an introduction. And now I would just briefly mention what we are going to showcase today, and then Frank will take over. No, I missed that slide. Sorry, my bad. Frank added this. Your fault. So
No
Frank,
problem.
would you like to tell us something?
Well, actually, this is exactly what I'm going to show live. And basically, the idea is, or the recap, I have a part from a customer that I need to treat. If I'm questioning it, it's a new part, because if it's a repeat part, I know it. So it's a new part, new material. new specs. I'm not 100% sure. So am I using the correct recipe? So that's the first question I want to ask myself. Then, does this recipe give results that are expected, statistically good results? And of course, it's tied to the recipe and it's tied to the asset. So will this furnace give me repeatable results? And of course, are there any anomalies and are there any alarms lately? So that's the direction I'm going to go, but I'm going to show it to you from the QMULUS point of view. So I'm going to take over screen sharing. Oh, no, actually, yeah, just give us a short.
No, that's fine. Frank already prepared to take over the screen. I just wanted to mention that we are talking about asset management application today, different dashboarding solutions we have built in, alarm statistics, performance dashboard, production dashboard, and Grafana for self-service dashboarding. We will talk about anomaly detection and last but not least, a notification service, which also keeps you well informed at any time. So Frank, now it's time to take over.
So I will share screen. Share. You should see screen number 2, which is this one. Okay. So starting from our app overview, login. These are all the apps I see. And remember, I have this part. I don't know exactly which recipe I should run it in, but I'd like to have an idea of what I've done in the past. So if I go to audit and quality, which I already launched here, I go into my audit and quality, and I have now, actually, this is a new feature, quality statistics. In quality statistics, I'm basically showing you all parts, all assets, all surface hardness. So if I did a quality report and I measured surface hardness, then it would show up here. If I did white layer, then it would show up here. Now, of course, understand that we just did a couple of spot checks. So we only have 3 results, or 4, actually 6 results. So the pool of data is small because it's a new application. Okay, we didn't develop it, finish. There's another. There was a previous question where okay, I could sort by part, I could sort by asset, but can I sort by recipe? So yeah, we want to put all these filters. That's good. That was a good suggestion. So in any case, I'm looking and I'm like, okay, fine, 12 microns is good. I'm interested in this. This process on this material might work for me. So this gives me a big overview. But tied to this, or in my future expansion of this tool, I have history and trends. So if I go to my furnace itself, I could see those same data, but this data was entered in a different way. And it was basically whatever. But the point is we're in dev. Okay, that's the point here. So I see my surface hardness on various samples here, filtered by a certain recipe. This is the recipe that is most likely the one I'm interested in. It gives the results I want. I have my K-step, I have the white layer, I get the results more or less what I want. So I'm interested in this recipe. And I could see that over the last 6 months, the results are more or less stable, with the exception really of this guy and this point and this point. So, but still, these points were September of last year. So why did that happen? I can go into it, but I don't want to go into it right now. I'm just trusting the fact that recently the furnace is giving results that are as expected. So I'm happy with the choice of recipe and I'm happy with the choice of furnace. Okay, but now I'm going to go to the next level and examine the furnace in detail. So if I go into my alarm statistics for my furnace in question, I open up all my alarms over the last year, and I could see that I had, 10 of these alarms, 36 of these alarms, and 44 of these alarms. Now, okay, it is interesting, but if I look at it on a Pareto graph, I could see, in a nutshell, I could see that there are 30% or 194 instances of furnace low pressure warning. which between me and you does not bother me about the results of my next job, because I know that this is most likely guaranteed. I have a set point during like a zero flow stage, and my pressure transducer has a negative 0.2, 0.6 offset. So my furnace pressure is negative, and I get this warning. So right now, standing here, I ignore it. But if I look at this next one here, I have nitrogen. So I have a nitrogen low warning, or here even an ammonia low warning. So these are two alarms that worry me more. Is it okay? Is my result, will my results be okay if I have gas problems? So now I'm a little more worried, but I'm going to look at it from another point of view. So yes, I had 97 nitrogen alarms, but now I'm going to look at it not from quantity, but from date, right? So if I look on a history point of view, I can see that my nitrogen alarms more or less all happen around March, April last year. So after that, we're clean. So whatever this problem was, it's over. However, if I go into my ammonia here, low warning, I do have some here around the date, October of last year, which is still a little while ago, but still, I may want to investigate. Hey guys, what happened to M1? Did we do any maintenance on ammonia master controller, nitrogen master controllers, filters, gas supplies, that type of thing? Also interesting that this field worked out nicely, where a furnace had water alarm problems. And if you superimpose this information with another furnace, with another furnace, with another furnace, and they all have water alarm problems at 2 in the morning, well, guess what? Your water pressure goes down at 2 in the morning so that the flow is too low. So it's not a furnace problem, but it's actually a plant problem. But I can only see that when I see the same behavior in multiple furnaces at the same time. So interesting to analyze, right? So I have basically come to the conclusion, like I just summed up what Mike was trying to say. I got my part. I used my quality data to tell me what cycle is most likely a good candidate. I then go in and analyze that particular recipe in that particular furnace. I analyze my statistical analysis, and will it give me the results I want? And finally, I go look at the actual asset, and are there any issues lately that I might be worried?
Yeah, that's true. From part one question, which bothers me a bit, and I'm a bit concerned about that. Is this asset, in any case, is it feasible? Can we run it? Does it have the required certificates? And how do we make sure that we are just running it on a machine which is capable of doing that, which is compliant?
Okay, that's a good point. So now it's the story is a little bit different, because now the part that you were given is not just a door handle, but it now has to follow some specifications. So can I run a NADCAP part in a non-NADCAP certified furnace? That's the question we're asking ourselves. So now let's go to asset management. So in asset management, every asset has its own asset management subsection pages. Okay, so the first overview, the first at a glance, what I see, I have a serial number, model serial number, which is important. Me receiving the phone calls, if a customer calls me and tells me they have a problem with R4, if they give me the serial number, I can find their drawings. So this helps me. That's one. Other than that, of course, they could walk over to the actual furnace and look at the nameplate. That's true. But if they're at their desk talking to me, and they didn't do it before, this helps. Now, Mike, what you were talking about was certificates. I could lock certificates, or even temperature uniformity survey temperatures. I could lock them to an asset. So this particular furnace has Boeing capability and is NADCAP approved. And there's a company called Safran that allows me to run the parts in this particular furnace. So I can, obviously as an admin, I enable these certificates on this asset so that as an operator, yes, I should not use this part in that furnace, but as QMULUS, we will prevent planning a load that does not have the proper certifications or even temperature, right? I have a min temp and a max temp, which is basically temperature uniformity. So it was certified up until 600 degrees C. So if a process is asking for 630 degrees C, I technically should not run it because I legally don't know what temperature is going to be in the furnace at 630. So QMULUS can prevent me from making those type of mistakes by preventing load planning on this particular furnace, something that is outside of these specifications.
Yeah, that's good. One thing we would like to mention briefly, exactly, this is statistics. I would just like to mention that because we are going to show later on the performance dashboard, and this target productivity set here to 80%, you will see that number later on. So please remember that we can just configure it here, and we will explain it later on as well.
As an admin, I would set this number to be what I expect my furnace to run. So if I am running 24/7 and no holidays, no weekends, no 4th of July, then this is 100% productivity. I expect my furnace to run all the time. So if the lid is open and the parts are on the floor, I'm non-productive. On the flip side, I expect to run this furnace from Monday to Friday, 3 shifts. Saturday, Sunday, I expect it to be off. So that's a different productivity objective. And of course, I could run only 2 shifts 5 days a week. That's whatever.
Yeah,
so this number, this number is set by admin. And this number, we're going to see it a little later.
Exactly.
Now, the next one is dear to me. Okay, so if any one of you listeners are deal with somewhat equipment maintenance, it happens very often in our world where we're leaving our office and heading with our lunchbox to the cafeteria, and someone stops me and says, "Hey, Frank, why is this valve not turning on?" So it's kind of easy to see which breaker, which fuse, which wire, and all that. Even with a little multimeter, I could tell if there's power or not, but I need to know what's the wire number because I don't know by heart. So I'd love to have the drawings, which in theory, the drawings should be at the bottom of the panel. But in realistically, the drawings are not always at the bottom of the panel. So we have in asset management, we have the possibility of tying documents to the asset. So I upload electrical drawings, I upload maintenance manuals, I upload other different manuals into this particular asset. Now, if I'm interested in the R4 electrical drawings, I literally just have to click here and I download them. So I don't have to go find them, they're easy. Of course, this assumes I'm sitting at my desk, but chances are I have my lunchbox and I'm on my way to the cafeteria and I need these drawings now. So let me show you how we've done this. So remember that what you're looking at here is literally a web page. This has a URL like any other, and because we're in Amazon, it's accessible by anywhere, by anything. So take this and convert it to...
In theory, yeah, as ever, for sure you can restrict the access and so on and whitelist the devices. So don't get us wrong here.
Of course. In
theory, there are security limitations.
Okay, sorry, I didn't want to make it sound really open. However, of course, I logged in. That's the first thing, right? So Frank has access to this particular Amazon instance.
Yes.
Okay, so since I logged in, I can click download and I download. But where was I getting at? So then this URL here can easily be converted to a QR code. And converting it easily to a QR code, I easily can stick it on my panels. So I have the QR code printed on my furnaces so that I can easily just walk in. So I'm not going to do audio. I'm just going to show you. Hopefully the resolution is okay. So this is me approaching the panel. I have, for some reason, I need my electrical drawings. So what do? I can easily grab it with my phone, which is definitely, try to read electrical drawings on your phone. That's okay. But I have a tablet with me. So use the camera app, get the URL, click on the URL. URL brings me to that same page I just showed you. And now the web page is going to pop up. This particular furnace was R8. So you can see R8 over here. I see all the documents, right? I have here electrical schematics. I have here manuals, alarms, and this and that. But I go down to my electrical schematics. I click download, processing, downloading the drawings. Poof, here are my drawings. So I find this extremely, extremely useful. You copy paste the URL, you go to a free URL to QR generator, print out stickers, go put them on your panel. Beautiful. Now, we went through this. The last thing, the last ones, I just want to go quickly, and I'll just stick to sensor settings. So now, this will bring us into anomaly detection and AI and all that type of thing. So QMULUS is looking at data. Data comes from sensors. So what's a sensor? Temperature is numbers, pressure is numbers, flows is numbers. It doesn't know what's what. But what's important is certain sensors, we tie them to what we call meanings. Sorry, I went too fast there. Hold on. I want to get, I want to show you a nice little group here. The group meaning I chose furnace pressure, and this is furnace pressure reading. A furnace pressure reading is the device, a pressure transducer. It is a physical device that gives a number, and it gives pressure in this case, and it gives it 24 hours a day. Running a cycle, not running a cycle. Cover open, cover closed. You always have a 4 to 20 milliamp signal. But what's important here is this. I'll just do a drop down so we could see the value. So you see this pressure is moving, is alive, it's reacting. That's the reading. But I gave this other sensor another meaning called absolute pressure set point. Now it's set point because it's a set point to him, right? So this furnace pressure is a set point to this furnace pressure. I have made a link. I have told QMULUS that these two should behave as action reaction, as a set point act value. So QMULUS will constantly be watching this. So QMULUS is going to observe how fast did my reading approach set point? How accurate did it reach that point? Was there a deviation? Was the deviation today greater or less than the deviation yesterday? Those are ideas of what QMULUS is doing in the background. Obviously statistics, okay? Nothing great, nothing magical. But it needs to know that there's a link, and this is the link. So when I take an act value and I link it with a set point, and these need not be a physical sensor. It could be a virtual sensor that we discussed last time. It could be the hottest thermocouple of 12, right? So once I have a sensor, I then can give it a meaning, and this meaning can then be tied to a set point, and that link is made.
Yep, that's exactly the point. And as Frank already said, QMULUS is directly, after each load, it's checking the health of these control loops, let's call it like that. And Frank already mentioned that we have three kind of KPI we are calculating out of it. The one is the agility, the other one is the precision, and the last one is the accuracy. And with these three values, having these three values in mind, we can just check if the state or the behavior is just moving in the right direction, or is it constant? Is it showing some outliers, and so on. That's the idea of the anomaly detection. Yeah. So maybe we can just
anomaly detection.
You can go for anomaly detection, or just briefly go for the manual, which we also would like to mention. It's always available by clicking on the question mark on the bottom left in QMULUS. You can just open it. It's a web-based manual, which is currently only available in English, so it won't be any problem for you, but you can translate it with your built-in browser capabilities, so that's no problem. We opened it already, and Frank just browsed through to the right section. We are talking about control features, as we already said, so pairs of set values and readings. And just to let you know what's the difference between accuracy and precision, for example, we have this picture. Pretty easy to grab once you have this picture in front of you. Otherwise, it's really hard to explain. Yeah. So, for example, top left, we talk about low accuracy because it would be just accurate. So the error between set point and reading would be low if we would hit exactly the middle of this. What is it called, Frank? Bullseye. Yes. Okay. Yeah. Then it would be high accurate. We see that, for example, on the right. Yeah, which is also high precision. But yeah, so that would be our over goal always. But we see on the left low accuracy, so we are missing the target. No, top above.
Oh, this one. Okay.
Yeah, we are missing the target, but at least we are missing it with some, continuously bad.
Repeatable.
Repeatedly,
Very
repeatable. Yeah, exactly. So there's no hard deviation. Nothing in terms of, okay, it's just deviation based. In contrary, we have the bottom right, which has a high accuracy. So if you just take the average of all the measurements, it fits perfectly to the exactly in the bullseye, but it's deviating a lot. So the precision is low while the accuracy is high. High. Sorry, I'm missing everything. And the worst case for sure is bottom left. Yeah, everything is all over the place. Yeah, so nothing we would like to achieve. So these are the first two KPIs we have. Accuracy, precision, and last but not least, we have the agility, which is just mentioned below. But this is comes mainly down to the speed. So how long does it take for a signal to reach the new set point? Yeah, or for the process to get in the whatever balance state of the temperature, for example. This is something which you would measure with the agility. Okay, so let's jump directly to anomaly detections, since we now talked about the basics. And anomaly detection, we have it open here for furnace Montreal R4. We already had that before. On the very left on the axis, you see different signals, which we have already seen before. Ammonia flow, we see chamber temperature. These are all the meanings Frank has shown before. Yeah, so these have been mapped. There are existing pairs of set values and readings for that. And what QMULUS is now detecting are outliers, drifts, and trends. While drift is something we are just being continuously above or below the statistical average. A trend is more like, okay, we have 5 values in a row which are just showing in one direction, but to the top or to the bottom. Yeah, so we have increase or a decrease continuously, and we have these so-called outliers which are just out of bounds. If you click on one of these, for example, we are talking now here about upper control limit exceeded, so this is an outlier to the top. We see the statistical deviation as we have seen it in history of trends, for example, and we see the last point representing the point we just clicked. It's an outlier, and it's a clear outlier. We are around 12, while we are usually around 2. Yeah, and this is percentage, by the way. So it's normalized. Nothing to worry about. It's just giving you us an indication. Yeah, so we are not talking about absolute errors. We are talking about just the region in which it should stay. As said, we have 3 different kinds, and we have always shown the direction. So, for example, orange is always to the top or rising, while blue is always to the bottom or decreasing. Yeah, so these are the indicators. These are anomalies detected in the configured control loops. Yeah, so these are the things. So what to do now with it? We have, for example, the nitrogen flow control accuracy. If you click on it, for example, we can see some details, these 2 points which we have seen. And if you just open that now, we can also see different root causes. Where do these root causes come from? we have pre-configured some generic root causes to certain things which are concerning flows, for example. So flows, they are really generic root causes. They are control valve defects, supply line leakage, whatever. But you can go ahead and say, I would like to create my own root causes. I have my maintenance crew here with me, my maintenance, my guy in charge. I have my Frank with me. And Frank could just tell us, yeah, come on, if you have a nitrogen flow control accuracy problem, I can investigate. And after I investigate, I can have found out that I have to, let's say, I have to fasten a screw or whatever. I have to check if the line is not blocked. Yeah, exactly. Whatever.
Pressure regulator.
Whatever you say, Frank. You are the boss here. You are the expert, and you would know what to enter here. So it comes down from really generic root causes to really specific thing. And additionally, which we would see if you just close that maybe and go to the main page of the anomaly detection. Go for R5 maybe. It's easier. It's faster to navigate.
R5 is a bad furnace.
Yeah, then go back to R4. Sorry, go back to R4 because you have seen that. We see directly when opening this application the possible root causes. Now on the left axis, you see control error, control valve defect, gas supply insufficient. You see all these generic root causes which I already mentioned. And why do we see these? We see these because we have observed anomalies which are indicating that. So this is really the result of our anomaly detection. Yeah, not fine-tuned because nobody spent time to put the right root causes, but you get all the things which could be a root cause to the knowledge of the system. So if you have some experts being able to teach the system, meaning giving their feedback, adding information, it would learn and it would come around with better suggestions of possible root causes. And as well, we could see that if you open flow measurement defect, maybe click on that arrow on the bottom, you could also add directly some recommended counteractions, yeah, which are also in this case pretty generic, but you have the freedom here to manipulate whatever you like, to integrate and add data, whatever you would like to see here. So that's really a short introduction into anomaly detection. I would like to lead over to the notification system, because what are all these anomalies worth, and root cause analysis as well worth, if you don't get to know about that. You cannot just scroll every time through all the screens. So that's why we have our notification system coming into play.
Okay, so I'll choose my own user. And as you could see, I'm able to subscribe to various anomalies or alarms or that type of thing. However, before I go there, I'd like to bring you into bring it up to the point that I can get an in-app notification, an email notification, or an SMS notification. Now, email, SMS, I'll get it on my email or get it on my phone. And in-app is basically this. This little icon now has a bell with an indication telling me that there's something that it wants to show me. There's something that it wants to bring up. So if I open up my my notification window, which I have a lot, basically M37 started a new job and D5 started a new job and S5 started a new job, because as you can see, in-app notification, I am subscribed to a job has been started. So that's why I'm seeing all of these here. Of course, if I were to jump, maybe why not? I'll jump to a furnace, then I will jump to the production log of the current situation where it's in right now.
Yes, exactly. So, and all these shortcuts are available for all the different signals, sorry, not signals, events. So if there would be an alarm, the notification for alarm, you could directly jump to remote control. With anomaly detection, you jump directly to anomaly detection, not with an anomaly detected, you jump to the anomaly detection, and so on. You can also receive the information via different channels. Frank mentioned that already. We have in-app, email, SMS. We also have the freedom to create new events on base of whatever you like to see. So that's also possible here. So this comes really handy, and also it allows for some custom notification. We are also going to add a filter for different assets. So if you're only responsible for a group of assets or only one asset, you can just subscribe for that asset. Currently, you would need to subscribe for all the assets, which is in most cases not a problem. But yeah, we will add this as well to allow for more customization and tailor-made configurations. Okay, so that said, so let's talk about the last topic of today, which is dashboarding.
Yeah,
which is always a huge topic.
So dashboarding is basically I need to see data, right? I need to have an idea of as a whole. So alarm statistics, we went through this. It's extremely powerful, extremely well laid out, but it's extremely discussed. We spoke about it many times, so I'm just gonna mention it's there and jump. Performance dashboard is the tool used for productivity. What percentage are my furnaces being used? That answers this question. So things like your typical green, which is actual production time, to gray, which is no production. Those you can see here as a number. So I don't know, 76% of actual versus 23% no. But you also have here orange, which is planned downtime. And here's a blue, which is actual downtime, 5%, 4.7%. Now, what's interesting here is I'm from a global or a point of view of Michigan, and I could see as my December 2024, which is my 5 weeks, I could see my individual furnaces grouped up by week, grouped up by month, in this case, December. Bring your attention to this black line, right? So here, the last in the text is target productivity 90%, target productivity 50%, target productivity 80%. That's that famous percentage that you saw back in the asset. So we have purposely chosen various numbers just in our demo here, so that you get to see a perspective from what is expected productivity, right? And it could be different for every asset. Now, if I take all of this data and group it up into 1 month, then I end up in the second row here, which is all M2 during the entire month, not by weeks, all M36. So actually, this polar and this stack bar are actually the same information in a different presentation. Okay, but it's still, this is the entire month. Now, the entire month, but still broken up by asset. And now if I go next step, I get to see the entire month, all assets. So all assets have been in productive for 41.16%, but all assets have been 57.84% not productive. So this is like the third layer. If I want the details exist in a tabular manner, which is not so useful in HTML language. However, I can export, get this in CSV, open up into Excel, and make my boss happy.
Yeah, exactly. You can also show maybe that if you click on one of the bars on the left, for example, M1, click on the M1 bar, maybe you can also see that it's has some drill down functionality. So now you see only exclusively M1 for the
per week.
selected. Exactly.
And then M1 per month. And this is my M1 data only.
Exactly. And the polar chart does not make any sense. That's why it's gone.
Yeah.
Exactly. So you have the freedom of doing everything here. Okay, so I think that's enough for performance dashboard. It gives you also already something at hand to play around with the productivity, let's say, figures.
Yeah.
Okay.
So now we'll go to production data.
Yep.
So production statistics is more of a consumption. How much water did I use? How much ammonia did I use? How much natural gas did I use? How much energy did I use? And how much did I use in the plant? How much did I use on the furnace? And how much did I use per recipe? So I could go down to that point. And actually, I am showing you here ammonia, CO2, and nitrogen for, let's say, Michigan. Of course, this is our dev environment. All of January, I get to see that in all of my furnaces, we ran 133 jobs with 12,000 meters cubed of ammonia, which is an average of 100 meters cubed of ammonia per job. CO2 is 479, and okay, basically whatever. What's interesting here is my preset shows me this, but I can change it. So first of all, I could go and edit whatever you see meanings or predetermined variables that already exist. But what I could also do is add a panel, which I have medium or large. What you saw before was large, so I'll choose a medium, and we're going to make totals of, and I'll stick with the same information so it looks repetitive. You'll get to appreciate it more. No, not natural gas. I want nitrogen and ammonia, right? So I have now my total consumption of ammonia graphically, which is basically this number here. But then I could go next level and make it total but distributed, and I'm going to make it medium, and I'll choose the same ammonia and nitrogen, right? So this tells me the ammonia consumption per job with a max, average, min, and same thing for nitrogen because that's what I chose. And last, let me show you this one. Is also very interesting. The totals, but of all the children. Okay, and I'll make this one large.
Yeah,
I'll make it large. Yeah, I'll keep it large because it's nicer. Ammonia, nitrogen. Okay. Now I get to see that. Remember, we're in all of Michigan, all of December, and these are all of my furnaces with the respective, let's say, ammonia and nitrogen consumptions. So I could easily see that my three biggest users are these three, right? M37, M36, M11. And let's say it stops here. Of course, I could save this as my default, and next time I log in, it'll be like this. But if I go in to my M11 and I drill down to a particular furnace, so now it's the same thing like before. I started from big and I go small. Now I could start from the middle and go smaller. So as you can see now, this is only M11. Oh, sorry. This is only M11. And these are the jobs that ran.
Recipes.
Jobs. Okay, sorry. Recipes. I used the wrong word. These are the recipes that ran. And actually 11 times we ran this recipe, and one time we ran this recipe with the same information that you saw before, with the same information we saw before, with now down by recipe. So this recipe, this recipe, this recipe, I can see these two recipes are visually equivalent in terms of gas consumption, whereas this one is obviously uses a lot less gas, i.e. it might be a lot shorter, whatever, but graphically, I get this. I'm sorry. Graphically, I appreciate all this information because it's just right there in my face. Perfect overview. We're running out of time.
Drill down. Now we can just drill down one times further because I would like to see now maybe how the distribution into different jobs was.
So I'll take this one because there's 11.
Yeah, exactly.
So yeah,
just for the sake of showing it. So you can really go down to the different jobs.
So these are all the dates.
Yes.
At which they ran.
Yeah, go down. We would just like to see the table. Not the table, the chart. And we can just visually interpret, okay, how was the consumption? Was it exactly in the same direction, or was it really deviating a lot? For sure, you can do that with the box whisker plot, which we have seen before, but this is, I think, also a cool thing to use.
Yeah.
Okay. And as you already mentioned, we are running out of time. So briefly, really
We're
briefly.
going to jump to Grafana.
Exactly.
So Grafana is, it's an add-on. Well, not an, it's a external open source application that we have adopted into QMULUS. So think of Grafana as the graphical overview of databases. Yeah. And since all of our database, all of our information is in the database, it is relatively easy to use Grafana to, I'm not going to use the word program, but to drag and drop one of these gauges and then edit the gauge to look up between this date and that date, between this asset, that asset, whatever, and find this data. So for example, here, the time that the furnace was above 900 microns, this was a vacuum furnace. So the vacuum furnace in the last recipe, because the gauge is of the last recipe, when the furnace was below 900 microns, it's not counting, not counting, not counting, not counting. When it's above, it's counting 1 minute, 2 minutes, 3 minutes. And then the whole recipe stops, so the cycle start over. So that means that in the last cycle, it was 26.6 minutes down. Now this, we chose it to be a gauge, and we could choose it to be historical, like here, for example, time that the furnace is above 900 microns. And now you can see your tendency. So in this particular date, the furnace was, basically what this means is the furnace had an open door with the pump system off for 7 hours, 32 minutes. So, and this is very configurable.
Exactly. You can just compare it with the solutions you might know. There is Power BI, which is really prominent on the market as a product from Microsoft. A lot of people are using that to connect whatever information they have to it and create whatever representation. You have the freedom to use every tool what's available in Grafana, and to let you know, Grafana is was the first available solution for that, so it has more than everybody else. So that's just said, we would like to close that webinar. So Frank, I am going to take over as usual. I have to check, where's my Zoom? Here's my Zoom. And here we go. So apps in Spotlight, we had that already. I think we did not leave anything out. So question and answer. Question and answer. So let's see, what questions do we have? Let me briefly check the question and answer section. One question for you, Frank. Is there a file size restriction or a file restriction for the number of uploaded documents in the asset management?
Actually, there is, but it might be something like 10 megs. I forgot. It might be actually written here, because at one point I surpassed it. I upload a document. I don't know.
Okay.
I think it's 10 megs.
I think it's fully configurable, yeah. So if you let us know, okay, you need not 10 megabytes,
okay. So you're hiding
or
this.
20 or 30, we can just configure that. The problem is that you are maybe using it as your trash bin. That's a problem. So we need to restrict that a bit also with malware, which you could upload potentially. So that is always a security issue, and we are flexible. It depends really on your needs, and yeah, there's definitely no restriction in terms of number.
In theory, you could put some procedures that are video, right? This is how you load the rack. Click,
exactly.
click.
Yeah.
And then the size gets big fast.
Yeah, I think we would then need to reconsider how we are storing these things, because they might not be fast enough in the S3, for example. Okay, but we could really consider that and find a solution. And last question for today. Can maintenance directly link to observed, or I think there's a missing a B. Can maintenance directly be linked to observed anomalies?
What do you mean? So I receive
this is a question, sorry. No, okay. I think the question is clear. So if I observe an anomaly, can I directly click somewhere and create a maintenance event out of it? So I think that is
so actually, I have to go to my anomalies. So we're starting off with anomalies.
Yeah, you're not sharing, so be careful.
Oh, okay. So let's share then. Share, yes. Here. Let's just start home. Oh, I'm not sharing still. Share. Yes, I'm sharing now. I'm not 100% sure I understand the question, but let's go to anomaly, and let's go back to our whatever. Montreal R4 observation by group feature. So if I notice that here there is this dissociation issue, if I click here, I'm shown my my history of this particular point.
Yeah. And the question is, we
that's not
would
the
now
question.
have determined, I think the question is now you have determined that there's something wrong. Can I just click on it or somewhere to create a maintenance task out of it?
Wouldn't it be here?
I think it's not possible yet. So don't look for it. This is something we can easily integrate because we are currently overhauling the whole maintenance calendar stuff. And the maintenance calendar is exactly for this purpose. The maintenance calendar can be used to schedule maintenance, to assign it to certain maintenance people. And for sure, it would be really helpful. And I got your point to create, maybe by just acknowledging the anomaly to create a maintenance event. I think that makes sense.
Oh, yeah. I know what you mean now. So I'm alerted to a trend detected or something.
Yeah, exactly.
And from there, I'm gonna say, okay, fine. So tomorrow at 2 PM, I'm gonna put the furnace down for 2 hours, and we're going to replace so
Exactly.
and so.
Yeah, exactly.
I understand. Yeah, today
Yeah.
both entities are 100% unrelated. I learned this, then I close this, I open up my calendar, and
Yeah, exactly. You have to do it by hand today.
yeah. Okay.
Yeah, but in the end, we have both the tools at hand. We just need to connect it, and this is fully a valid question and a future enhancement we are going to integrate. Okay, I think that's enough for today. So let me briefly take over again, and let's close the meeting properly. So we go, here we go, here we go, here we go. So you're seeing my screen again because I would like to invite you for the next webinar topic and webinars topic that will be advanced tech. I already mentioned that it will be about AI, predictions of quality, predictions of sensor behavior, and so on. So it will be really interesting, and we will also see how predictions can play a crucial part in our anomaly detection and how it will enhance what we already have seen. Maybe we will also see something about our simulators. Let's see if we can find someone in our company to show it to you, because I'm definitely not the right guy to present a simulator to the audience. But thank you very much for attending. I would like to see you again on 19th of February. You will receive your invitation as usual from the marketing team. Thanks to all who are helping making this happen, and thanks Frank for
Thank you.
presentation.
Thank you. Thank you, everyone.